Hello student, in this video I am going to discuss about video compression, or we can directly go to the MPEG-4, that is MP4, that is used to compress the video. That is a version of MPEG, or you can say encoding technique, compression technique used in case of video or in case of audio. Also in case of audio it is named as MPEG-3, but in case of video it is MPEG-4. So here what we know that compression is reversible conversion, or you can say encoding of data that contains fewer bits. This allows a more efficient storage and transmission of the data. The inverse process called decompression, when we increase or try to make the original original file. Software hardware that can encode or decode are called decoders, but combined from a codec means coder and decoder. So that is why code means encode and decode, that is codec. Should not be confused with the terms that data container or compression algorithms. So codec is not like data container or compression algorithm. It is just a combining process of encoding and decoding. So here you can see relation between codec, data containers, and compression algorithms. Here we can say data containers are those like, here you can see MPEG, AVI, ASF, and QuickTime. And also this is codec, means it can like here you can see decodes. When it decodes it's called decoders, when it encodes then it's encoder or coder, but combined from a codec, and should not be confused with terms data container. So codec does not like data container, or codec does not like compression algorithm. It is both actually. Like narrow, if the software you have used narrow, someone might be like DivX, HZX4, or Real Video. Those are like codec, or you can say software which can code or encode the same video. Codec implements the compression algorithms. It packs coded files into this type of format. Okay, so codec packs the coded files in this and implements this type of compression algorithm. It might be MPEG-1, MPEG-2, or it's 2.261, or MPEG-4, MJPG. So lossless compression allows a 100% recovery of the original data. If you follow the lossless compression, you might be able to recover the whole original data. It is usually used for text or executable files where loss of information is a major damage. These compression algorithms often use statistical information to reduce redundancies. Huffman coding, run length encoding are two popular examples, allowing high compression ratios depending on the data. Using logic compression does not allow any exact recovery of the original data. We know that, and nevertheless it can be used for data which is not very sensitive to losses and which contains a lot of redundancies, such as image, video, and sound. So in case of image, video, and sound, we can go for lossy compression because there might be that redundancies containing in the data. But in case of text, like files, we need to go with that lossless compression, because if you lose some information, we might not gain that after recovering it. So that is why in case of video or image or sound, we might go for lossy compression. So lossy compression allows higher compression ratios than lossless compression. That is why we might lose some data, and we have that flexibility to lose the data. Why is video compression used? A simple calculation shows that an uncompressed video produces an enormous amount of data. A resolution of 720 into 576 pixels, or PAL, with refresh of 25 fps and 8-bit color depth, would require following bandwidth: 720 into 576 into 25 frames per second and 8-bit color depth, plus 2 into, that is 2 into 360 into 576 plus 25 into 8, that is the chrominance values actually here. Okay, this is actually required for the bandwidth. So this is multicolored, and that is why this will become 1.66 MB per second to send the data. For high definition television, then it will become more like this: 1920 into 1080 into 60 into 8 plus, that is the pixel value, and into 2 into 960 plus 1080 plus 60 into 8, that is 1.99 GB per second. Even the powerful computer system, storage, processor power, network bandwidth, such the amount cause extreme high computational demands for managing data. Fortunately, digital video contains a great deal of redundancy, thus it is suitable for compression, which can reduce this problem significantly. Especially lossy compression techniques deliver high compression ratios for video data. However, one must keep in mind that there is always a trade-off between data size and quality. The higher the compression ratio, the lower the size. So, higher the compression ratio, the lower the size and the lower the quality, obviously. And the encoding and decoding process itself also needs computational resources which have to be taken into consideration. It makes no sense, for example, for real-time application with low bandwidth requirements, to compress the video with computational expensive algorithm which takes too long to encode and decode the data. So we might not go for those type of software or algorithm which take lots of amount of time to encode or decode the data. We might go for that type of algorithm which will take less amount of time to encode or decode the data, because that is also a serious thing in the concern. And not only, no, we cannot go for that much amount of encoding or decoding which will lose lots of data, and also it will reduce the quality too much. We need to go for a higher platform, like we might go for compression to that extent that only give us a balance line, like we can have a visible quality of video along with good quality of compression ratio, like that. So here you can see image and video compression standards. The following compression standards are most now known nowadays. Each of them is suited for specific applications. Top end is the lowest. Top end is the lowest, and last row is the most recent standard. MPEG standards are most widely used ones, which will be explained in more detail in the following sections. So we'll try to go for MPEG standards in this video or in the continuous video. But here you can see JPEG is the still image compression, which has been developed first. Then it goes like this, and this one second and third, fourth, fifth. So in that way it has been come to the picture of human world. So still image compression, that is bitrate is variable. Bitrate is variable in case of H2.261 video conferencing over ISDN. That is P into 64 kilobyte per second. And MPEG 1, MPEG 2, H2.260, these three also for video on digital storage media, or it might be digital television or video telephony over ESDN. There is also MPEG 4, object-based coding, synthetic coding, content, interactivity. We can interact with the content, variables. The bitrate is variable. But here there are some limits also. In case of JPEG 2000, improved still image compression, that is variable also. Bitrate is variable also. So these are different type of. Last one is H.264, or we can say MPEG 4 AVC, improved video compression, and the bitrate is 10 second to 100 tens to hundreds kbps. MPEG standards. MPEG stands for moving picture coding exports group. That is the full form of MPEG. At the same time, it describes the whole family of international standards for compression of audio visual digital data. The most known are MPEG 1, MPEG 2 or MPEG 4, which are also known as ISO IEC 11172 or ISO IEC 13818. Those are actually actual standard name which has been as a research product, and it has been standardized by the regarding institutions, and that is the numbers actually for those patents. More details about MPEG standards can be found in you can go for these references 4, 5, 6. The most important aspects are we can get in this document. So the MPEG standard published in 1992, first one, and its aim was to provide VHS quality with it. VHS means VHS means video home system quality with a bandwidth of 1.5 MB per second, which allowed to play a video in real time from a one CD-ROM. The frame rate in MPEG 1 is locked at 25 pixel 25 into 25 pixel FPS frame per second, and 20 pixel frame per second, or you can say 20 frame per second, and 30 NTSC FPS 30 FPS respectively. Further, MPEG 1 designed to allow a fast forward and backward search and a synchronization of audio and video, a stable behavior in cases of data loss, as well as low computation times for encoding and decoding was reached, which is important for symmetric application like video telephony. So this is some history of MPEG 1, MPEG 2, MPEG 4, and here you can see in the figure also MPEG 4 is the largest one. MPEG is the original. MPEG 2 is created upon MPEG 1, and MPEG 4 is used the technology of MPEG 1 and MPEG 2 and created a newer version of MPEG. So basic things about MPEG compression is that in 5 steps, it takes 5 steps to compress the data. First, the reduction of the resolution is done. So first stage is reduction of the resolution, which is followed by motion compensation in order to reduce temporal redundancy. So after reducing the resolution, a motion compensation is done to reduce the temporal redundancy. Temporal redundancy means we try to reduce the data in case of time. The next steps are the discrete cosine transformation, which is used also in case of JPEG, and quantization, as it is used for the JPEG compression. This reduces the spatial redundancy. So in case of both video or image, in case of video also actually is nothing but a set of images. So obviously if we go for JPEG type compression in case of every frame, then obviously you can reduce the spatial redundancy, so which is done by using the discrete cosine transform and quantization. So first what is done is that we need to reduce the resolution, then we need to go for motion compensation to reduce the temporal redundancy, and next step was to use same like JPEG, where discrete cosine transform and quantization is used for the compression of the spatial redundancy, referring to human visual perception. The final step is an entropy coding using the run length encoding and a Huffman coding algorithm. So in the last step, Huffman coding and run length encoding is used to create the entropy coding. So step 1 is that the human eye has a lower sensibility to color information than to dark bright contrast. So low sensibility to color information than to dark bright contrast. A conversion from RGB color space into YUV color components help to use this effect for compression. So what is the work here is that a conversion from RGB color space into YUV. So YUV and help to use this effect for compression. The chrominance components U and V can be reduced to half of the pixel in horizontal direction. This 4:2:2, or a half of the pixel in both the horizontal vertical direction, that is 4:2:0. So we can reduce the original value by that much depending upon the subsampling. 2 or 4 pixel values, here you can see, depending upon the subsampling, 2 or 4 pixel values of the chrominance channel can be grouped together. Means here you can see 2 or 4 pixels can be grouped together. So subsampling reduces data volumes by 50%, 44.4:2:0, and by 33% for 4:2:2 sampling, because you can follow this one. If initially suppose we think that y equal to u equal to v, then if we take the ratio in this order 4:2:0, then it will be like this is the equation of the if we using that ratio equation, then in the below of the this uh, denominator, so y plus u plus v and y plus 1/4 of u plus 1/4 of v equal to half, because it will become half of this, and then 4:2:0, if we take 4:2:0, then it will become 2/3. so in that way actually if we take 4:2:0, this is 4:4, but in that way uh, so y component is 4, u component is 2, v component is 0 in this case, but in this case y component is 4, u component is 2, and v component is 2. That is also why u v color component help us to use this effect for compression. Chrominance component u and v can be reduced subsampling to half of the pixels in horizontal directions, or half of the pixels in both horizontal and vertical. If you go for both horizontal and vertical, then it will be 0. If you go only for horizontal direction, then it will be 4:2:2. Next one is motion estimation. An MPEG video can be understood as a consequence and as a sequence of frames. So it is the second step. First step is reduction of the resolution. Second step is motion estimation. So MPEG video can be understood as a sequence of frames, because two successive frames of a video sequence often have small differences except in scene images or scene changes. The MPEG standards offers a way to reduce this temporal redundancy. It uses three types of frames. The I frames are keyframes. So here you can see I frame, P frame, and B frame. I frame is intra, P frame is predicted, B frames is bidirectional. So it uses the three type of frames. The I frames are keyframes which have no reference to other frames and their compression is not that high. The P frames can be predicted from an earlier I frame or P frame. So there might be more than one P frame, but there will be one I frame which is a key frame, and P frame will be predicted by using the I frame and P frame. P frames cannot be reconstructed without their referencing frame. So referencing frame might be I or P, and P frame cannot be constructed without the help of I or P, or using the both. So but they need less space than the I frames, because only the differences are stored. So only in case of P frames we store the differences between the consequent frames. So B frames are two directional version of the P frame, referring to both direction, one forward frame, one backward frame. So in the B frames actually we can store the information of one forward frame and one backward frame. So B frames cannot be referenced by other P or B frames because they are interpolated from forward and backward frames. So B frame cannot be referenced by other P or B frames. So P frames and B frames are called intercoded frames, whereas I frames are known as intracoded frames. So here you can see in this number of frames, here MPEG frame sequence with two possible references, a P frame referring to I frame and a B frame referring to P frames. Here I in that is intra frames, B for bidirectional, forward or might be, backward might be, and P is differences between two consequent frames. The usage of the particular frame type defines the quality of the compression ratio of the compressed video. So I-frame increase the quality, I-frames increase the quality and size, whereas the uses of B-frames compresses better but also produces poorer quality. The distance between two I-frames can be seen as a measure for the quality of MPEG video. So the distance between two intra-frame values is the important key concept about the quality of the MPEG video. In practice, the following sequence showed to give good results for quality and compression levels. Means here I, double B, P, double B, P, double B, P, double B, I. So this is almost, here you can see this part is almost palindrome. So this is one B will be backward, one will be forward, then P frame, difference between these two B, or depending upon the one I, depending upon I. So again 2B P, again 2B P. So P can be generated using I and P also. So but B cannot be referenced from I or P. Okay, it just gives some idea about forward and backward frames. So I will continue from this point in the next video. Till then, please try to go through this context also, go through this document also, and you can go through other materials that will be uploaded in the Google Classroom, and also in literature, from the literatures can be found in the internet. So try to go through this. It is interesting to understand about MP4 or MPEG-4 or any other MPEG or video compression techniques. So that's it. If you have any confusion or doubt or anything to add, please let me know. We'll try to resolve that over Google Meet. Thank you.